Here we have the integral of the product of two functions of x, so I think integration by parts, and normally the function I would call u would be the one that would go to 0 if I differentiate enough times. However, exceptions to that rule are going to be if the other function is not easy to integrate, and this is the case here with tan inverse of 2x. That's also going to be the case for things like natural logs of something, inverse trig functions, things like that. So what I'm going to do is I'm going to actually call this function u because I can differentiate that a lot easier than I can integrate it, and then my dv is going to be what's left there. So I've got u equal tan inverse of 2x, so du equals 1 over 1 plus our 2x squared, and then we got the chain rule multiplied by the derivative of 2x. Now our dv is 3x dx, so if I integrate that to figure out what v is, that would have been one higher power there, but I'm going to need that reciprocal of that power out in front, so that's going to be 3/2 x squared. So now let's go ahead and apply our integration by parts formula and see what we get. We have uv, so that's going to be 3/2 x squared tan inverse of 2x minus integral of v, that's 3/2 x squared du, that's 2 over 1 plus 4x squared, and I should have had a dx right there, dx. Alright, so let's see where we are. We can cancel these, and I'm going to go down to the bottom and write this integral. It's going to be negative integral of 3x squared over 1 plus 4x squared dx. Now, in looking to integrate that, I have a quotient, and anytime I have a quotient and the degree of the numerator is equal to or greater than the denominator, which is this case, I am actually going to do long division to rewrite this kind of split up. Now I'm going to take the 3 and move it out of the way because that will just complicate things. And so what I'm going to do is long division dividing x squared by, and I'll put the x squared term first, 4x squared plus 1. So I divide that into this, and the way to think about it is what do I multiply 4x squared by to get x squared, and that needs to be just a 1/4. 1/4 times 4x squared is x squared, and 1/4 times 1 is 1/4. Then I subtract. That changes these signs, those are gone. So I have left this negative 1/4, so I put negative 1/4 over the divisor, which was 4x squared plus 1. So this integral will break down into an integral that looks like this. Now why I would do that is because then this is something that I can integrate. So let's go ahead and continue back up here. So let's rewrite our first part. We have 3/2 x squared tan inverse of 2x, and then we are going to have minus 3 that we had out in front when we did that, so I need to put that right here if we're looking at this being our integral. Maybe I better write that. So we're going to have minus, and that's actually going to be 3/4. If I put it out in front, that's just going to be of a dx, and then this other one's going to be plus 3/4 with an integral of, and I'm going to write it 1 plus 4x squared, turn them around again so we can see how to integrate that. Okay, I'm going to erase this bottom stuff where I did the division so that I've got room to finish the problem. So we have 3/2 x squared tan inverse of 2x, and this would just be minus 3/4 x. Now here, if I would have had this, I know that that's inverse tan of 2x, and I almost have that. I could bring the 3/4 out in front, and then I could put a 2 there that I need if I compensate for that by putting a 1/2 out in front as well. So if I have out in front a 3/8, then I would have here this integral, which ends up being tan inverse of 2x, because we see that's the function we had here when we differentiated inverse tangent of 2x. And then we would have plus a constant.